So good afternoon again. So I'm going to spend some time eulogizing the optics. But I'm going to say something positive of optics. My idea is to address the backbenchers, not the front bench. All right. For the front bench, it will be like, as we say, रामायण राम को ही सुनाना, तो वो तो मैं करने वाला नहीं हूँ, because they are all experts in optics. So this is mainly for students, and what I'm going to do is to introduce you to how optics has grown and what are the things that we look forward to, what are going to happen now in future. So that is why I have given the name photonics revolution, because that is what we believe that photonics revolution is going on at the moment. So this is a collage of many personalities of the last century. They were all active in the last century. You have people from politics, science, national, international, and so on. So the question is, what is common among them? What is common? The common is that all wearing specs. Right? And they were very active till very late in life, and they must have started wearing their specs at the 30 or 40, around 30 or something like that. So good amount of their life would not have been so productive if they did not have these specs. So this is the bag, same thing. The most famous specs are, of course, Mahatma Gandhi specs, and spectacles are the invaluable vision aid for the humanity. 75% of adults in the world use some kind of vision aid, whether spectacles or contact lenses. In India, 35% of population are in need of this kind of correction. But only 25% of these have access to this. So you can imagine that how much work is still left to be done in this particular area. So this is one example of a simplest optical instrument which has been in the aid of humanity for the last about 8 centuries. First spectacles appeared in the 13th century or so. This is an example of optics and photonics around us. Another example which was ubiquitous was this particular non-contact thermometer during Corona times. Whenever you wanted to enter a building, the guard will put a gun on your head and will tell you whether you can go or not. This is an optical instrument. And so is this oxygenation meter, which most of us had at home who could afford, to see whether Corona is really affecting us, to what extent, and so on. This was a very valuable thing at that time. These are both optical instruments. We all have mobile phone in our hands, and this mobile phone has so much optics and photonics in it that some part you know. For example, camera. In fact, now when you go from one generation to the next generation of phone, the main thing that changes is the camera. You are just looking at whether the camera is good or not. You use most of the time this particular device for actually for its camera rather than anything else. Then you have flash lamp, of course. No torches now. Earlier in old times we used to have torch in our hands. Nobody needs a torch now. It's integrated here. The internet is optical. We'll talk about that. Display is LCD display. Is all optical device. And the machining, manufacturing is all laser based. There was an article in 2012, I think, that laser enables smartphone manufacturing, and it says that laser processing plays a critical role in fabricating nearly every significant component in these products. So whether you have PCB fabrication, drilling, display glass cutting, touchscreen patterning, brighter displays, everything is actually photonic or optical. In fact, one example I can give you, this display glass cutting, very simple thing. most of your phone keep falling, but the glass does not crack very easily. You have to work very hard to make it crack. Because the cutting of the edges of the glass is by laser. You know, shear cutting, which is like, you know, when you cut with a machine, it creates micro cracks which travel with time and make it fragile. Whereas laser cutting is fusion cutting. So there are no cracks created. And that is why these are very, very sturdy. So this is just one example of changing of the technology and making it happen. And there are a whole lot of things which we look around in our daily life. One example here again I can point out is the laser bar scanners. If you did not have these scanners, you will not have the mall culture in the world. Because the fast moving selling process can only be done with these bar scanners. This is just one example. Otherwise, whole lot of things which are happening today. Lighting has completely changed. All this lighting is LED now. This is completely changed over the years. Of course, all other lighting were also photonic devices or optical devices, whether you have a lamp or a incandescent lamp or fluorescent lamp or any other kind of lamp. But LED has completely changed the process. I think Professor Dinesh Kabra will talk about such things more than I can. But whole kind of decorative lighting all over the world. Every place you will see, now Diwali is coming, you will see all LED galore around us. One negative thing that is happening is the car headlights. They have become so bright that you actually become blind when you are coming in front of any particular car. That problem has to be solved at some point, but that is what is happening. So light has been at work all along, quietly, silently, behind the scene, and these are some of the examples that I showed. But of course, the real kick was given by the invention of laser in 1960, and I'll talk about that later. So, some of the things before lasers. Optical instrument aided astronomy. Without a telescope, there will be no astrophysics, there will be no astronomy. So, we talk about a lot of things, discovering various galaxies and so on. Everything is because of the telescope. And we are making bigger and bigger and more higher resolution telescopes even now. Microscopes. Without microscope, there is no medicine, there is no biology. And even today, we are trying to make microscopes which can see smaller and smaller. In fact, people are trying to make movies for the biological processes which are happening at the very, very small scale. 2014 Nobel Prize was given for microscopy. Without spectroscopy, science or chemistry or material science will not progress. It's very, very important. So these are three examples where whole areas have been aided by optics. But when we talk about astrophysics, astronomy, we don't stop for a second and think about the telescope. We just see the data and analyze that and so on. So optical technology has been the enabling technology. That's the part here. It enables many things, but it's not there on its own completely, and it continues to be so. So light is the energy that we are talking about. Optics is the science of light, and this light is very, very small part of a huge electromagnetic spectrum. Very small part, and that is what we are talking about. Optics is the science of light. Photonics is the science and technology of light. And the photonics revolution is that we are witnessing today. In 2015, the UNESCO declared the year as the International Year of Light and Light-Based Technologies. It was driven by mainly two things. One was the optical fiber communication. The other was LED, white LED that has come by that time. And it was a very successful event. And to perpetuate that, it was also declared that May 16th will be celebrated as the International Day of Light. and this started in 2018 after this. So I would urge the chapter here to do some major activity at that particular time. Unfortunately, this time is such that this falls in the vacation or the exam period, but you can probably shift a little bit here and there and see, but you must celebrate this activity. So, photonics revolution, on the most fundamental level, through photosynthesis, light is necessary to the existence of life itself on Earth, and the many applications of light have revolutionized society through medicine, communication, entertainment, and culture. So, in fact, the entire energy on Earth that we have, all forms of energy, are because of the sun. All, whatever solar light you are getting, which is the form of light radiation, is what creates, whether it is petroleum or it is wood or it is hydrogen. Everything is conversion of that energy into the other forms of energy. The only energy form which is diffusion energy, which is not by this, or nuclear energy, which is the source of course, solar energy also. But all other forms are from here. Light and photonics are poised to become key enabling technologies of the future. All over the globe, people are using light to discover solutions of the society's most pressing problems, from 3D printing to bringing energy solutions to developing regions. Light is the key in driving economies, encouraging the development of civilization. All these statements I'm saying are the statements which are given by the UNESCO committee while proposing the International Year of Light to the United Nations. Economy is expected to grow, or is actually growing at around 8%, 7.5 to 8%, and it is expected that it will become something like more than 1,000 billion, that is 1 trillion in 2028. Corona made a little setback on these things, but it was still, now it's come back to this. If you look at the world map, the dark blue areas are the ones where the photonics activities are supposed to be very heightened in now or in the future, which includes China, India, and Australia, these places. But of course, these kind of reports say that China will be the manufacturer, India will be the market. So it is for us to change that. We should also become some kind of manufacturing nation. And these are various areas listed here, where this is expected to play important role. This report is a little older than you don't see the quantum here, but quantum is something which has come up a little later. So Nobel Prizes, if you look at the history of Nobel Prizes, till 1960, when the lasers were invented, laser was invented in 1960, till 1960 only 4 Nobel Prizes were given to areas connected with optics. After that, you can see there are 16 Nobel Prizes were given since then in the areas of optics, and you can see the density is sort of quite defined. In fact, it's increasing as you go towards today's time. In fact, in 2014 and 2023, both physics and chemistry Nobel Prizes went to optics. So what was the scenario at the end of the 19th century? By the end of the 19th century, the electromagnetic theory of light was well established, experimentally proved, and everything was done. It was very well established. Experiments also verified the theory and explained the optics. Whatever optics was known was actually explained on the basis of that. Michelson has stated in one of the documents in 1894 that it seems probable that most of the grand underlying principles have been firmly established. An eminent physicist remarked that the future truths of physical science are to be looked in the 6 places of decimal. What he meant was that you have to make more and more accurate measurements. Theories are all known, principles are only what is remaining is to know things more accurately. This he had written for a manual in the university for the experimental physics. So that is what he has written. But this is, as we say, he spoke a little too soon, because immediately after that, the quantum physics came, and the whole physics and the whole science was, upturned or upside down. So what are the major things that happened in the 20th century in terms of photonics? The establishment of light quantum, photon, through the work of Einstein and others in the early 20th century. Einstein also predicted in 1917 the mechanism of stimulated emission of radiation, which actually became the basis for lasers. In 1928, Raman discovered his effect, which opened a whole new branch in spectroscopy. Holography was invented in 1948 as a completely new imaging process. And the first laser was made in 1957, which was the first use of stimulated emission process. And then soon after, the first laser, ruby laser, was made in 1960, and it was declared on May 16th in that year. That is why May 16th is actually celebrated as the International Day of Light today. Okay, this has completely changed. Lasers ushered a new phase of activities in optics. So much so, a new word called photonics had to be coined to encompass, to give the weight of the activities that are going on. Just optics was not sufficient. It expanded a little. Last 65 years have seen innumerable innovations and developments in the field of optics and photonics. As I said earlier, only 4 Nobel Prizes were pre-laser and 16 have been post-laser for nearly 60 years each. So lasers actually sowed the seeds for the photonics revolution that we are witnessing today. So what are the things, developments for waiting for a source like laser? That means the principles were known, but they were not going anywhere. So this is holography and interferometry. You needed a source with large coherence length. Coherence length means the light source, if you divide the beam into 2 parts and join them together, if they are kind of, they know each other or they are correlated, how much difference can be there in their paths. So that is a measure of coherence length. Larger the coherence, better interferometry you can do, better holography you can do. So with Leith and Opetnik's 1963 development of off-axis holography, after the lasers were developed in 1960, holography and its application to various fields including interferometry and non-destructive testing led to the recognition of Gabor's of 1948 work with the Nobel Prize in 1971. Nonlinear optics and spectroscopy, especially Raman spectroscopy, needed a source with very high intensity because nonlinear processes are very weak in efficiency. So you need a very high input beam to create a nonlinear effect. So nonlinear optics, particularly with ultra-short laser pulses, broke new grounds in science and engineering, while laser and Raman spectroscopy with new techniques like LIBS made new ground in molecular detection and sensing. Blumbergen and Shallow won the Nobel Prize in 1981 for their work in laser spectroscopy. And communication. The third thing is communication. It needed a source with high intensity and high directionality, and laser provided that. The dream of communication engineers of using optical frequencies for communication to gain an advantage of 10⁵ in terms of data rates, data capacities, became a reality with lasers. Optical communication have played an important role in the spread of knowledge economy of today. Today we say all knowledge economy is because of its connectivity in the way societies connect and communicate today. In wide-ranging impact was recognized by Nobel Prize in 2009 to C.K. Kao's seminal work of single paper in 1965. Okay, so these are the main application areas. There are many more they are developing. Communication with lasers and fibers, energy, lighting, solar cells, lasers, health, imaging, sensing and therapy, industrial application, manufacturing, sensing and control, defense, vision devices, detection devices, target annihilation and so on, and many others. So if I just briefly say word of internet, because about waveguides, Professor Anurag Sharma will talk, I think maybe, I don't know, Sivabrata will also talk about, I don't know what is, maybe similar. So I'll not go into much detail, but what I'll say is this is again UNESCO committed that social media, low-cost telephone calls, video conferencing with family and friends, these are 3 examples how the internet allows people around the world to feel connected in a way that has never been possible in the history. And all this terminology is because of light. And that is why they said that should happen internationally have light. So internet revolution is taking place on the back of optical fibers. Optical fibers are thin, extremely thin, flexible, transparent fibers made of silica or plastic, mainly silica. These hair-like fibers transmit light signals from one end to another over long distances when joined together. Most commonly used in telecommunication, the use of light in fiber optics has revolutionized the way humans interact in the 21st century. Another thing is the fibers are also used because signals travel through them with less loss than in metal wires, and also they are not affected by the electromagnetic interference. So these are two very big advantages. People will not know what EMI or electromagnetic interference is today because we are all using optical communication. When I was your age, at that time we used to have telephones with wires and we could hear a lot of noises because of this EMI at that time. So optical fibers were used since mid-20th century as optical elements to transmit light and images for applications such as endoscopy, which was a medical device, and a person called Narendra Singh Kapani, an Indian, he was from Dehradun, actually contributed so much that he was called father of fiber optics. In 1950s, Kapani invented the glass-coated glass rod. That means, as we commonly understand today, in a fiber you have a core and you have a cladding, but that concept was not very established, and he was the one who showed for the first time that if you do that, then you can make a better fiber. Coined the familiar phrase fiber optics was actually coined by him, and he wrote the first book on fiber optics ever. And in the 50s, Hopkins and Kapani made extensive studies on optical fiber bundles for making medical endoscopes. When he died in 2021, so this is what New York Times said, that the N.S. Kapani, father of fiber optics, died at 94. So he was actually very big. But he did not contribute much in the communication side, and that is why people say that he did not get the Nobel Prize or part of the Nobel Prize or whatever. But he was not very sore about that. In one of the interviews said, it's okay. The subject is recognized. Anyway, he was a chief guest in 1998 at Photonics conference at IIT Delhi. So I have met him personally. I met him personally also in the US later on, earlier than that. Sorry. Okay. So what was the thing? The problem was the fibers which Kapani was using were made from glass, and they had a lot of loss. Now, in an endoscope is this much, half a meter long thing, so the loss did not really matter. But when you have for communication, you need kilometers, then the loss becomes important. And the losses were typically 100 to 200 dBs per kilometer, which is a no-go. You had hardly any signal left on the other side. What Gao showed, for which he got the Nobel Prize, that actually this loss was not because of glass, it was because of impurities. And if you can somehow, in the manufacturing process, purify glass, then you can actually get rid of this. And this is precisely what was done by a team of Corning, by Maurer, Keck and Schultz in 1970 to fabricate a glass fiber which was 17 dBs per kilometer. And that was the breakthrough. And this whole thing got him the Nobel Prize in 2009. So because of this internet, because of this optical fiber, the internet was possible. Because then you could communicate, you could connect, and the connection was low loss, very broadband, and so on. And so the internet was established in 1993 or so, and initially only 1% of the traffic was on the internet. But by